Okay, so before we learned about the and probability and the or probability, different types of probability situations, today we're going to learn about one more called conditional probability. So conditional probability is just when you're taking the probability of an event, but you have some given information. You know something for sure about your outcomes. Probability of an event with some given information. So you know something for sure. Oops, you know something for sure about the outcome. So there's a couple phrasings that can be used to denote this given information. So one can be where it asks like the probability of event E given F. It can just tell you what's given, or like given F, what's the probability of E. Or it could be like, what's the probability of E if F? So if F is true, in that case, F again is the given information. Or it could start with if. If F is true, then what's the probability of E? So the word given is not always going to be explicitly written, so you just have to be able to kind of pick out what's going on. So again, what conditional probability does is it is essentially narrowing down your sample space, because if you know something for sure about your outcome, then that narrows down where you're going to be looking for, your possible outcomes. So example 1, to kind of demonstrate this, so suppose we roll a die. What's the probability that the die comes up a 3? So there's one way to roll a 3 out of 6 possible outcomes normally, so 0.17. But now example 2, suppose the die is rolled, but we are told the outcome will be an odd number. So we know it's going to be odd. This is given. And whatever the given information is, that's what's going to help you find your new denominator. So in this case, we know it's an odd number. There are 3 odd numbers to choose from. Since there's 3 odds, and that's given. And then of those 3 odds, one of them is the number 3. So our probability just increased because we were able to get rid of half of our possible outcomes because we were given some information about that outcome. So conditional probabilities change or lower the amount of possible outcomes, which again is your denominator or the sample space. So it's the sample space, which affects the denominator. Okay, something else that we're going to be using with conditional probabilities a lot, and with our or and probabilities as well, are these two-way frequency tables. So I just want to go over these. So how to read them: we have one variable set over here, and so each row, like this is the freshmen, this is the sophomores. So this says like we have 60 total freshmen, we have 40 total sophomores. And then vertically, we have whether they carry a credit card or they don't carry a credit card. So 80 total people carry a credit card, 20 total people don't carry a credit card. Now, in the middle of this is where we have overlaps, like the and probability. So and is the overlaps. So like where we have credit card carrier and freshmen, where they overlap right here, that means 50 people are freshmen and own a credit card. Or over here, we have 10 people are a sophomore and do not own a credit card. And then this number in the lower right-hand corner just tells us the total number of people. Okay, so let's do some questions using this information. So letter A, if a student is selected at random, what is the probability that they carry a credit card? So probability that they carry a credit card would just be the number of people with a credit card divided by total number of people. So here, we don't care if they're freshman or sophomore, we just care if they have a credit card or not. So it's just the total number of credit card carriers over the total number of people. So it'd be 80 over 100, or 0.80. Okay. Letter B, a student is selected at random. What's the probability that they are a sophomore or do not carry a credit card? So remember our or probability. Probability of sophomore or no credit card would be equal to the probability that they're a sophomore plus the probability they don't have a credit card, then minus the overlap, which would be that they're a sophomore and don't have a credit card. So the probability that they're a sophomore, regardless of whether they have a credit card or not, 40 total sophomores over the 100 total, plus the probability they do not have a credit card, again, regardless of whether they're freshman or sophomore, 20 people don't have a credit card, and then minus the overlap, which again is one of those middle numbers, minus the probability that they're a sophomore and do not carry a credit card, which is 10. And again, it's all over the total number of people. This would be 50 over 100, or 0.50. Let's clean this up here. So now letter C is where we get into our given probabilities. So if a student is selected at random, find the probability that he or she owns a credit card given that the student is a freshman. So we know for a fact that the student we care about is a freshman. And so that means we only care about our freshman numbers here. We know that they're a freshman. We know they're not a sophomore. So we don't care about the sophomore stuff or the totals because we know our person's a freshman, so we're only going to focus on those numbers. So since we know they're a freshman, this is now our new total because that's our given. And now of those freshmen, what's the probability that they own a credit card? Well, 50 of the freshmen own credit cards. So it'd be 50 over 60, which would be 0.83. All right. So the formula to calculate this conditional probability, or the conditional probability rule, says the probability of F given E. So that little line here means given, and whatever comes after it is the given event. Probability of F given E, and it would equal the and probability on top, so the probability that F and E occur, which is why we took that in this one. We took the overlap here, credit card and freshman. That was our numerator. And then the denominator is the probability of the given event, because that's the one we know for sure. So again, the one you know for sure, the one that comes second, is always the given probability. That's always the given information. Now, you'll notice here I'm talking about probabilities, but when we did this calculation up here, we just did the number of. You can do that calculation the same way. Number of outcomes in F and E in the overlap, and number of outcomes in E is the same. It'll give you the same thing. So if you're given probabilities, use the probabilities. If you're just given number of outcomes, like in these tables, then just use the number of outcomes. Okay, so example 4 is just some practice using this rule. So I want you guys to go ahead and try example 4A and B. So you're going to use this rule, plug in the probabilities you know, and solve for the ones that you don't. So go ahead, try example 4A and B. Okay, and then example 5, so using the same table here, compute the probability that a randomly selected student does not carry a credit card given they are a sophomore. So given they're a sophomore, this is what we know for sure. So I'm going to highlight my sophomores. I only care about sophomores, nobody else. Any numbers I use for my probability has to come from this sophomore row. So our rule would be the probability that they do not carry a credit card and are a sophomore, which is 10, over the probability that they are a sophomore, the number of outcomes that they're a sophomore. So 10 out of 40 would be 0.25. Okay, so letter B, compute the probability that a randomly selected student who carries a credit card is a freshman. So this is one of those situations where the word given is not explicitly written there, but if you read it, we want to find the probability that a randomly selected student who carries a credit card, we know this to be true, is a freshman. So this is our given information that they carry a credit card. So any numbers you use to do your calculations for your probability has to come from that credit card carrying column. So I want you guys to go ahead and try letter B. Okay. Example 6 now is a situation where I'm giving you the probabilities. Now, these are in percent form right now with the probabilities. We want to make sure that before we do any calculations, we write our percents as decimals. Write percents as decimals before doing any calculating. So we have the probability that a day is cloudy is 37%, so probability that it's cloudy would be 0.37. And the probability that the day is cloudy and rainy is 0.21. So then it wants to know what is the probability that in Chicago on a randomly selected day in June it will be rainy if it is cloudy. If it is cloudy is the given information, so that's going to be your new denominator. So probability of rainy given cloudy would be the probability that it's rainy and cloudy divided by the given probability, which is that it's cloudy. And so also, when in doubt, the larger probability or the larger number should always go in the denominator. So and is 0.21, cloudy is 0.37, this one's a larger one, a larger number should always be in the denominator, because or else we'd end up with a probability larger than 1, which we can't have. So helpful hint, if you're ever unsure, it's always the larger one that goes in the denominator. So that would give us a probability of 0.57. Okay, examples 7 and 8 are just some refreshers on our and probabilities. I want you guys to go ahead and try examples 7 and 8. Okay, and then there's going to be some self-assessments, or quick check self-assessment. Bring any questions you have to the Google Meet. To make sure with these percents here, you change these percents into decimals before you do any calculating. Okay, go ahead and try the quick check self-assessment. Bring any questions you have to the Google Meet.